Howdy, PreCal. It is Miss Kosh. We are doing 5C, evaluating series notes. So we talked a little bit about what a series is in the previous video, and so now we're going to start finding their values. Sorry. And I used some of the formulas already in that previous video, so maybe this one can go a little faster. Okay. So a bit of this is review from the previous video. First of all, converge or diverge. Well, this goes to infinity, and it's geometric, and its R value is 6, which is greater than 1. This will diverge. On this one, it goes to infinity. I see terms going. I see that this, if I multiply by negative 1/4, is my R value, and the absolute value of that, absolute value of negative 1/4, is less than 1, so this will converge. This one is arithmetic. That's all I need to know. It diverges. Okay, so we talked about this chart already. It's a repeat of it, and so now we're just going to jump in. I don't think I'm going to do all of these, but we'll do some that are relevant. So the first one, here's what I see. It's arithmetic and finite, so that's good. Okay, so then we can either use S sub n equals n over 2 times a sub 1 plus a sub n, or I can use, you know what, I'm going to find another arithmetic one. I'll do 2 arithmetic problems. The other version is S sub n is equal to n over 2 times 2 a sub 1 plus n minus 1 times d. I'll do, sometimes I like to do both formulas on the same one, and you can see that they work the same way. But to make this video go a little faster, I'll do one formula, and then I'll do the other one. Okay, so on this one, I'm going from 1 to 10, so I have a total of 10 terms. So that's 10 over 2. The first term is what I'm going to get when I plug in 1. So I'm going to have 15 minus 3 times 1. 15 minus 3 is 12. That's the first term. The last term that I care about is going to be 15 minus 3 times plug in 10. That's a negative 30. 15 minus 30 is a negative 15. So it's plus a negative, I was hoping to get rid of this, and it wasn't the last thing I wrote, so, you know. So it's 12 plus a negative 15, and so I see that this, I'm too lazy to go pull up Desmos, this is 5 times negative 3, which is negative 15. So if I wrote out these 10 terms and then added them all up, they would add up to negative 15. Let's look at this other one, doing the other, another formula, except here, think of this as not necessarily a sub 1. Think of this as the first term we care about. Okay, and we also talked about if I'm starting at the 5th term and going to the 25th term, I have to do 25 minus 5 plus 1. And so there are 21 terms that I'm trying to add here. So the sum of 21 terms is equal to 21 over 2 times the value of the first term we care about. So let's do 1/5 times 5 plus 2. 1/5 of 5 is 1 plus 2 is 3, so that's the first term we care about. Plus, how many terms do we care about? How many terms do we want? 21 minus 1. And my common difference, what am I doing each time? I'm multiplying it by 1/5. I lied. That was totally wrong. What am I doing each time? Well, so this, what looks like the slope becomes what my common difference. And so you could try by plugging in the first term to the second term, and anyway, that slope is the common difference. That was said terribly. I apologize. Friday afternoon, it's been a crazy week. Okay, so 20 times 1/5 is 4. You know, it was easier for me to plug this in here. That's 10. Half of 10 is 5. This is 21 times 5. That gives me 105. And that would be the sum of all those terms. If you added up all those individual terms, that's what you'd get. Now let's do a geometric one. There's only one formula for a finite geometric, and that's the sum of 7 terms is equal to, well, okay. It's the sum of n terms is equal to a sub 1 over 1 times 1 minus r to the n over 1 minus r. I will need to use Desmos here. This is the sum of 7 terms is equal to our first term. When I plug in 1, this goes to 0, so 5 to the 0 power is 1. So 2 times 1 is 2, and this is 1 minus my rate. My R value is 5. That's this right here. And I'm raising it to the 7th power over 1 minus 5. And let's see if I can get Desmos to come join me. Well, come back. Where is Desmos? You can see, there we go. We said our first term was 2 times 1, I need it to be and then 1 minus 5 is in the denominator, and then minus, I was too lazy to put in another parentheses, raised to the 7th power, and there's our answer, 39,062. So some of these geometric ones, they grow fast. So, did I remember that correctly? 062? Was I right? Yep. Okay. And there's there's a geometric one. Okay, so the next one, oh, there's some infinite. Oh, look, all three of these are infinity. This one, the limit does not exist. We can say that this one diverges. Don't tell me it goes to infinity or negative infinity. We don't have our sum can't add up to infinity. It has to add up to a number. This one also diverges, or then the sum does not exist. Because it's geometric and our r value is too big. Our r was greater than 1. R was equal to 6. Too big. Oh, I say that. Oh, I lied to you. I lied to you. This wasn't my worksheet. I'm sorry. Guess what? You get to watch me think in real time. Delete. Okay, what's happening here? This is why this is tricky. I caught it pretty quick, though. N equals, n is going... This is the sum, as n goes from 1 to infinity, of 3 times, well, what is this is saying 6 to the negative 1 to the n. Well, that's something very different. See how the negative, I can split that apart. Negative 1 times n is negative n. Well, 6 to the negative 1 is 1/6 to the n, and that 1/6 is less than 1, so this one will converge, and so we have to use the formula, the sum of the infinite sum is a sub 1 over 1 minus r. Notice I forgot to write that, which I often do. And so my first term, when I plug in 1, if I plug in a 1 right here, that means it's 3 times 1/6, which is 1/2. So my very first term is 1/2 divided by 1 minus 1/6. This is 1/2 divided by 5/6. Which if I multiply, dividing fractions, I can change flip, so I can multiply by the reciprocal. This goes in there, so this is equal to, we have a sum of 3/5. Whew, I almost went wrong on that one. That would have been bad. Okay, over here, we can also do this one because this is a little more of a standard setup for a geometric. Our first term, it's infinite. Our first term is equal to 10. Our common ratio is 1/2. So this is 10 divided by 1/2, which is the same thing as 10 times 2, which equals 20. I could grab a Desmos or a calculator, but these, if I write the math in such a way, it's faster for me to do that rather than go find the calculator. The next one, okay, this is geometric. Ew. Okay, we need, how many terms do we have? 12 minus 5 plus 1. 12 minus 5 is 7, plus 1 is 8, right? Because if I go 5, 6, 7, 8, 9, 10, 11, 12. I just counted out 8 numbers. Okay, and I did it on my fingers, but you couldn't see me, so I win or lose? I don't know, whatever. Okay, so this is, we have 8 terms. The first one I care about is going to be 4 times 2 to the 4th power. So 2 to the 4th is 2, 4, 8, 16. So times 4 is going to be 64. So the very first term I care about, we'll call it a sub 5, would be equal to negative 64. But so my formula, S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. We're tweaking that formula a little bit. It's not a sub 1 that we want, it's actually a sub 5 that we want. And it's not a total of 12 terms right here, it's actually that 8 that we talked about. So it's S sub 8 is equal to negative 64 times 1 minus, my r value is 2 to the n. How many? What was n? 8 over 1 minus 2. Okay, come back, Desmos. Negative 64 times 1, I wanted it in a fraction, 1 minus 2 goes in my denominator. 1 minus 2 to the 8th power. So negative 16,320. That was badly stated. Negative 16,320. There you go. All right. Okay. And the next one, this one here, this is what I thought I was looking at over here a second ago when I thought it diverged. That one didn't diverge. This one does. So here we have that our R value is equal to 6, which is bigger than 1, which is no good. So this diverges. And so we would say that the sum does not exist. On this one behaves almost identically to number 4 or number 6. I'm going to skip it. The only trick on this one is that the first term you care about is going to be 729 times 2/3 is, well, okay, I'm already halfway in. Let's, 729 times 2/3 is equal to 846. I read that wrong. 486, man. Okay, so over 1 minus, so this is the sum, the infinite sum is equal to a sub 1 over 1 minus r. The r value is 2/3, so I have 486 is being divided by 1/3, so that needs to get multiplied by 3. Multiplying it by 3 is going to just undo what I just tried to do. Is that right? Yep, 1458. Well, there you go. Okay. Now we can have scenarios where find the sum of that to 50 terms, write in sigma notation, then find the sum. So this is the sum as n goes from 1 to 50 of, well, I see an arithmetic sequence with a common difference of 3. And I see that my first term is equal to 4. And I can say a sub n is equal to a sub 1 plus n minus 1 times d. And so that first term was 4 plus n minus 1. My common difference we said was 3. You can technically plug that mess in there. It just gets, it's a little cumbersome. This is 3n. I see a negative 3 and a positive 4 gives me a positive 1. So write in sigma notation, then find the sum. My formula is, well, one version of it, S sub n is equal to n over 2 times 2 a sub 1 plus n minus 1 times d. It's a little bit easier this time because I don't have to find the 50th term, but it's whichever. So 50 over 2 times a sub 1 was 4 plus 50 minus 1 times my common difference was 3. Okay, come back, Desmos. What did I just type in? So I can type it in as we see this. 50 over 2 times 2 times 4 plus, well, 49 times 3. And we get, this is a sum of 3,875. Dun, 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 dun. Okay, so this one is, let's just write this sigma notation. I've worked in, this is geometric because we're multiplying by 3. So this is the sum as n goes from 1 to 10 of 2 times 3 to the n minus 1. And then I could use the formula. Okay, the first term of an infinite geometric series is 4. A sub 1 equals 4. Find the common ratio. Oh, find r. We don't know r. If the sum, infinite sum, is 16 over 5. So my formula, the infinite sum, is a sub 1 over 1 minus r. So this, 16 over 5, will be equal to 4 over 1 minus r. I can cross multiply. I get 20 is equal to 16 minus 16r. I'm going to add 16. 36 is equal to negative 16r. I'm going to divide by negative 16. And let's see, 4 goes in there, 9 and then 4. So I see that r is equal to negative, this doesn't make sense. Did I do something wrong? This first term is 4. Find the common ratio if the infinite sum is 16 over 5. Oh, did you catch my mistake? Because it took me a second. You know how I knew I was wrong? I was getting an r value that was not, it was negative, but its absolute value was not less than 1. I was getting something that was going to be like a negative 1.5 or negative, I don't know, 9 over, no, it was 2.25. It was negative 9 over 4, and I was like, that can't be right. Did you catch my mistake? Take another second, see if you can find it. Hit pause, see if you catch it before I tell you. Okay, did you figure it out? I forgot that when you subtract 16, you get 4. I added 16. You know, I'm good, but I'm not perfect. Okay, so 4 is equal to negative 16r. Now I'm getting to a place where I divide and I get r is equal to a negative 1/4. That makes sense because I can't have an infinite sum if my r value is bigger than positive 1 or smaller than negative 1. Okay, common ratio of a geometric series is that. Find the first term when the infinite term. Okay, so the common ratio, r is equal to 1/5. I prefer fractions to decimals. Find the first term. We don't know the first term if the infinite sum is 125. Okay, so s is equal to a sub 1 over 1 minus r. Let's plug in what we know. 125 is equal to a sub 1 over 1 minus 1/5. This might, well, let's see. Okay. So this is 125 is equal to a sub 1 over 4/5. So if I multiply both sides by 4/5, then that gives me 5 goes into 125, 25 times 4 is 100. And there we go. We have finished the notes. So like, subscribe, comment, and go practice. Good luck to you.